When the product is in the support stage, developer is not involved in the support stage. So developer involved only in the development stage. So to minimize the defects, we need to conduct the testing efficiently during the development stage itself. So in this testing strategy, internal details are not visible. Entire program is there without showing the internal working conditions. So here, whatever the testing we are going to analyze, that is robustness testing, that is comes under the category of a black box testing. Hello students, hi everyone. Welcome to Made Easy. Myself Sagar Pingili. In this session, we are going to discuss some important testing strategy used in the software testing. That testing strategy is the robustness testing. Robustness testing is the session topic. Right? So when we analyze the software development life cycle, there total we have 5 phases. In the 5 phases, 4 phases are in the development stage and 1 phase is present in the maintenance stage. So the total software development life cycle is divided into 2 parts. One is the development stage, second is the maintenance stage. So here in SDLC, software development life cycle, total 5 stages are there with the combination of development and maintenance stages, named as a requirement analysis stage, design stage, coding stage, testing stage, support stage. So total 5 stages present in the software development life cycle. Okay. In the analysis stage, system analyst is taking the responsibility to gather all the requirements needed in the software project. So system analyst responsibility is gathering the requirements based on the goal of a software, based on the goal of a problem statement, by using the different requirement engineering techniques. Requirement engineering present in the analysis stage to gather the requirements. After gathering all the requirements, document is prepared by the system analyst. That document name is called as the software requirement specification document, that is SRS document. So in the SRS document, we have a functional requirements and non-functional requirements. Based on the SRS document, designing will be takes place in the design stage. So here in the design stage, designer is present to design the document. SRS document is a plain English document. So designer taking the plain English document, translating that into a technical document. In that technical document, data structures present, flow charts present, data flow diagrams present, ER diagrams present, and so on. So simply plain English document is translated into a technical document. That document name is software design document, SDD document. Okay, so by using the different designing principles, designer prepare the document which contain the technical details. That document is called as the software design document. Okay, that SDD document is submitted to coding stage. In the coding stage, programmer or developer is present to translate the SDD document into a program. That program is called as the logical component. In this stage, different tools and technologies, languages used by the programmer to translate the SDD document into a logical component. Okay, that logical component is submitted to the testing stage. In the testing stage, tester is present. Tester take the responsibility to test the logical component to cover the errors. After testing, error-free logical component is present. That error-free logical component is a program or final software. Okay, that final software is deployed into a market. When the software is in a market, then support stage is standing there to maintain the software. Support. Here 4 types of the supports present, called as the correction support, adaptation support, enhancement support, prevention support. So to maintain the software from various side effects, support is required. Correct? When the product is in the support stage, developer is not involved in the support stage. So developer involved only in the development stage. When the product is in the development stage, then developer involvement is present. When the product is in the market, maintenance team involvement is present. Okay, all right. So these are the different stages present in the software development lifecycle. So here we are going to concentrate only on a testing. So our attention is only the testing. Okay. So what are the different testing strategies used in the testing stage to cover the errors? Okay. Then what is the goal of a tester? What is the objective of a tester? What are the different testing strategies are present in the software testing? Later, we are going to decide what is robustness testing in the software. Okay, all right. Now, if we see the testing, tester objective is, in the testing stage, testing team is there. You can say individually tester is there. Okay, tester is not a programmer, tester. Okay, so testing team objective is prove the system what extent it become failure. This is important here. What extent it become failure. This is the objective of a tester. Testing team objective is prove the system what extent it become failure. So failure is the major attention here. They want to prove the system under so and so condition it become failed. Under which condition system is failed, that condition will be reported to the development team. Now development team take the corresponding modification to cover the error. Therefore, objective of the testing team is prove the system what extent it become failure. So failure is the major attention in the testing stage. Okay. For example, testing team set the objective as a success. Prove the system what extent it is success. If that is the objective, there is a possibility of overlooking. There is a possibility of overlook. Reason is, when the tester is going to test the system with the input domain, from the input domain selecting one input, test the system. if the system produced the desired output, then software is success. When software is success, tester objective is satisfied. When the tester objective is satisfied, tester is not going to conduct the testing with other possible inputs. That is a overlook. Maybe system is perfect with only one particular input set. It may not be perfect with another kind of inputs. So, when the tester is unable to test the system with all possible inputs, there is a possibility of system errors. Those errors become a defects when the product is in the maintenance team. Okay, when defects are more, quality will be decreased. That is the reason testing team objective is prove the system what extent it is failure, not prove the system what extent it is success. Okay, so always testing team objective is prove the system what extent it is failure. Okay, see this. For example, this is the input data set. Here we have so many inputs. Okay, now software is ready. This is the software. Software is ready. When we are testing the software with the objective of success, then giving one input. Okay, this is the input selected. From the input domain, this input is selected, testing the system. After testing, check the output of a system. Suppose that output is legal. System given the legal output. Then we are concluding that software is success. When software is success, objective of the testing team is satisfied. If the objective, tester objective is success, then immediately testing team objective is satisfied. When the testing team objective is satisfied, there is a possibility of overlook. What is overlook? Further testing stopped. Because of objective is satisfied, remaining inputs are not tested by the tester. So these remaining inputs are not tested. When the system is okay with one input, if they are concluding that system is perfect, at the time of using the software, user identify the error. User identified error is called as the defect. When defects are more, quality of the software is less. That means quality inversely proportionate to number of defects. Is it okay? So to minimize the defects, we need to conduct the testing efficiently during the development stage itself. That is the reason tester objective is prove the system what extent it become failure. Okay, so testing may be conducted like this. See this. Here we have a input data set. Software is ready. When we are going to test the software, all possible combinations are used. For example, one input is selected from this. This is the input selected. Now test the system. Output is legal. System is success. But what is the objective of the tester? Failure. He want to prove the system what extent it is failure. But here system is success. Okay, objective is failure, but system is success. So tester objective not satisfied. When objective is not satisfied, apply the another input set. Apply the another input set. Like this, all possible inputs are tested. Under all cases, if tester unable to satisfy testing goal, ultimately system is success. There is no possibility of overlook if we set the objective like this. Okay, that is described clearly here. With all possible inputs, when we test the system, in all cases, if testing says system success, then tester objective is not satisfied, but system objective satisfied. So here overlook is not possible. Okay, see this, under all condition, when the test is unable to satisfy, testing team is unable to satisfy the objective of testing, then ultimately system is success. That's it. When the tester is unable to reach the goal, ultimately system goal is reached. So, testing team objective is prove the system what extent it become failure. If this is the objective, all possible inputs are examined without overlook. Hope you understand, right? So now here, whatever the testing we are conducting, that means giving the inputs, checking the outputs. Giving the inputs, checking the outputs. That is the testing only. Here we did the same procedure. Program is ready. We are giving the inputs to the program, checking the output of a program and proving that that output is legal or illegal. Okay. So this kind of the testing is called as the black box testing. Black box testing is the behavioral testing, also called as the gray box testing. So this black box testing concentrates only on the functionality of a system. We can say functional testing, black box testing, gray box testing, behavioral testing. These all are common names. So in this testing strategy, internal details are not visible. Entire program is there without showing the internal working conditions. So we just giving inputs and checking outputs. This kind of test strategy is called as the black box testing. Okay, when we have black box testing like this, there is an opposite also. That opposite is called as the white box testing. White box testing is nothing but a post-mortem of a program. White box, also named as the glass box, that is also called as the structural testing. So when we are keeping some program under the glass, that program is visible, transparency is there. That means internal parts examination is called as the white box testing. So we are going to concentrate on the internal parts examination. Each part is working or not. Each statement is working or not. Like that. So internal parts examination is the post-mortem. So post-mortem of a software is called as the white box testing or glass box testing or structural testing. Okay. So here, whatever the testing we are going to analyze, that is robustness testing, that is comes under the category of a black box testing. Okay, robustness testing is the black box testing strategy. Okay, so now here in black box testing, when we are going to test the system with inputs, suppose we have large set of inputs. We cannot able to test the system with all inputs. Each individual input is not going to be tested. Therefore, to conduct the testing efficiently, some strategies are present in the black box testing. Okay, in that strategies, equivalence partitioning, boundary value analysis, robustness testing, like that, black box test strategy follows different methods of testing. Okay, in that methods, robustness testing is one method to conduct the black box testing efficiently to cover more errors. Okay, then what is going to be happened in the robustness testing? How errors are covered efficiently? That we will see now, right? Okay, now if you see the software testing two types. One is the white box, second is the black box. So our current discussion, robustness testing. So robustness testing comes under the black box category. Black box category, right? So what is the major objective of robustness testing? Before understand this objective, we need to take the software experts analysis. Software expert analysis stating that more errors are occurred at boundaries rather than the center of a input domain. More errors occurred at boundaries rather than the center of a input domain. That means when we develop the software with some group of inputs, software is perfect with the given input set. Software may not be perfect when we are giving invalid inputs. So instead of testing the software with the center of the input domain, test the software with the boundaries. More errors occurred at boundaries rather than the center of the input domain, because we already developed the software with the proper input set. So software behavior is okay with the input set which we already given as a input domain to the software. So testing the software with the different values of that domain is not the criteria. Criteria is test the software at boundaries, because more errors possible at boundaries rather than the center of a input domain. When software expert analysis is stating like this, more errors are possible at boundaries rather than the center point. To cover more errors which are possible at boundaries, robustness testing strategy is used. Robustness testing strategy is used to cover more errors at boundaries. Okay, like this. Suppose this is the input domain. So many inputs are there. This is the software. Now, when you want to conduct the black box testing, we are giving the inputs. When you have a n number of inputs, no need to test the system with n inputs. Okay, when you have a n number of inputs, no need to test the system with n inputs. No need to conduct the n test cases. Then how many test cases are required? Answer is like this. Robustness testing concentrates only on the boundaries. Okay, now see this. Suppose this is the boundary. Okay, this is what? Lower boundary. Only assume this is a lower boundary. This is a upper boundary. Okay, so first conduct the testing with lower limit and conduct the testing with upper limit. So conduct the testing with lower limit, conduct the testing with upper limit. So two test cases are prepared. One is the lower limit test case, second is the upper limit test case. After that, conduct the testing just above and below the lower limit. ये देखो, just above and below the lower limit, just above and below the upper limit. Okay, conduct the testing at lower limit, at upper limit. Also conduct the testing just above the lower limit, just below the lower limit, just above the upper limit, just below the upper limit. Therefore, total 6 test strategies are required. See this? Here 3, here 3. Total 6 strategies required. 6 test cases required. Okay. One test case at lower limit, another test case at upper limit, okay, another test case at just above lower limit, another just below lower limit. another just above upper limit, another just below upper limit. Total 6 test cases are required to test the system to cover more errors at boundaries. Clear? Now only one test case used in the center. So center test case is only one, boundary test cases are 6. So total 7 test cases are developed. Later test the system with 7 test cases to cover more errors at boundaries. That testing is called as the robustness testing. Okay. So robustness testing is used to cover more errors at boundaries rather than the center of a input domain. That is this. So here 6 test cases conducted at boundaries, only one test case conducted at center of a input domain. Total 7 test cases are implemented in the software. Okay, to cover more errors at boundaries. To cover more errors at boundaries. So that is called as the robustness testing. To cover more errors at boundaries, robustness testing is used. Okay students, hope you understand this, right? Now let us see the example. Let us see the example. Suppose there is one variable present, name as a x, that is bounded between a and b. A and B is the input domain boundaries. So A to B, in between A to B data elements are accepted by the variable x. So A less than or equal to x less than or equal to B. So x is accepting the data values which are present between the A and B. A, B and between that. Okay. Lower limit is A. Upper limit is b. A is the lower limit, b is the upper limit for the variable x. Okay. Now robustness testing yields. When you want to conduct the robustness testing, as I explained earlier, 7 test cases are required. 7 test cases needed. Okay. Right. What are the 7 test cases? As I explained earlier, lower limit and upper limit. Later, just below and above the lower limit, just below and above the upper limit. Later, center. Right? Now see this. Lower limit is A minus 1. That means just below the lower limit. A, lower limit. A plus 1, just above the lower limit. A plus B divided by 2. This is the center. B minus 1, just below the upper limit. B upper limit, B plus 1 just above the upper limit. So whatever the concept I explained diagrammatically, that is explained here also. So to test one variable, 7 test cases are needed. In the 7 test cases, center test case is only 1, boundary test cases are 6. Okay, so here total 7 test cases. These all are the 7. So 7 test cases are developed. 7 test cases are developed in the robustness testing. After developing the 7 test cases, implementing the 7 test cases to cover the errors. In all test cases, if there is no errors detected, then conclude that system is successful. Is it okay? All right. If program is having only one variable, 7 test cases are required. Suppose program having more than one variable, how many test cases are needed? Okay. Now see this. Suppose we have a program. Suppose we have a program with 2 variables. I assumed 2 variables are in the program, x and y. These 2 variables are bounding between the data input domain 100 to 300. So these are accepting the data between 100 to 300, 100, 101, 102 and so on up to 300. This is the boundary of the variables input data. Right? Now robustness test. We are conducting the robustness. We are conducting the robustness testing. So in the robustness testing, for every variable, 7 test cases are required. Okay. Now when you want to conduct the robustness testing, where program contain 2 variables, keep one variable in the center of a input domain to test the another variable. Okay. Keep one variable in the center of a input domain to test the another variable. In this example, I took 2 variables x and y. When I want to test x, keep y in the center. When I want to test y, keep x in the center. Okay? When you want to test one variable, keep remaining variables in the center of a input domain. That is the robustness testing, test strategy preparations. Robustness testing, test case preparation. Okay? Now see this. To test variable x, observe, to test variable x, keep y variable in the center of a input domain. Keep y variable in the center of input domain. What is input domain center? 100 plus 300 divided by 2. That is 200. So y is keeping in the center. Test the x. Okay. Now what are the test cases? Lower limit is 100. Okay. So just below the lower limit, 99. Lower limit 100. Just above the lower limit, 101. Center 200. Just below the upper limit, 299. Upper limit 300. Just above the upper limit, 301. So now x variable is tested by using the robustness testing. There 7 test cases are there. 6 are at boundaries, 1 is at center. Like this. Okay, when I test x, y is in the center. Very good. Now to test y, keep x in the center. What is x here? 200. Now test y. Just below the lower limit, just above the lower limit. Center, just below the upper limit and just above the upper limit. Okay, now y variable is also tested by using the robustness testing. Okay, robustness testing for the y variable requires the 7 test cases. For the x variable also requires the 7 test cases. When I compare these test cases, center test case is common. Center test case is common, right? When we have a center test case is common, take it as common and remaining are different. So 6 test cases are different for each variable. So here I took 2 variables. So that 6 into 2, 12 plus 1, total 13 test cases are generated by using robustness testing. Okay. When the program having 2 variables, to conduct the testing by using robustness testing, 13 test cases are generated. Very nice. Center test case is common. Remaining test cases are different. Okay, students? Very nice. Now let us see the same thing diagrammatically. This is the diagrammatical analysis. Verify. Here it is clear, right? 100 to 300. This is the x variable. Let us say this is x. X variable accessing the inputs. Now this is a y variable. Y variable is accessing the inputs. So that input domain is 100 to 300. 100 to 300. This is the domain. Now center is 200. We keep the variable into center when you want to test another variable. Okay, alright. Now see, when I want to test the x variable, keeping y in the center. Okay, now this y is in the center, correct? This is in the center. Keep y in the center. Test the x. Now see, x 99. See, this is 99, frankly speaking. This test case is 99. Now this test case is 100. Now this test case is 101. Now common 200. Next this is 299. Next is 300. And last is 301. So, by keeping the y into center, we are testing the x. Keep the y into center, test the x variable. Okay. Now, if you want to test y variable, keep x in the center. Right? Now, this is x. X is in the center. Keep x in the center, test the y. Okay. Now, what is robustness testing? Robustness testing stating that prepare the test cases to cover more errors at boundaries. That is just above and below the lower limit and upper limit, and lower limit, upper limit, center. Like this, test cases are prepared in the robustness testing. Okay, now see this. So here testing is what? This is 99. This is 100. This is 101. Just below the lower limit, just above the lower limit. Next center, center is common. Now, just below the upper limit, 299. Upper limit, 300. Just above the upper limit, 301. Okay, students. So, diagrammatically, it is clearly visible to you how the robustness testing takes place. So, when we conduct the test operations at boundaries, there is a possibility of covering the more errors which are present at boundaries rather than the center of an input domain. That's what, when you see this diagram, here 6 test cases required to test the y variable at boundaries, okay, and 6 test cases required to test the x variable at boundaries. Later, one test case is always common. Common test case is only one. Okay, if 2 variables are there, each variable requires the 6 individual test cases and one common test case. So 2 into 6 plus 1. Suppose if you have n variables, if software contain n variables, now we have a n variables, then each variable requires the 6 individual test cases. Later, all the variables requires one common test case. Therefore, if software contain n variables, then robustness testing yields 6n plus 1 test cases. Clear? If software contain n variables, then robustness testing yields 6n plus 1 test cases. Okay, students? So, robustness testing used to cover more errors at boundaries rather than the center of a input domain. I mean to say that when we are developing the software with some input set, compulsory software is functioning properly with that input. Software is functioning properly with that input set. But problem is, if invalid data is given, invalid data means just above the, just below the upper and lower limits. If any invalid data is given, how the system is functioning, that is important. Okay, so here you say this is valid. Frankly speaking, 300 is valid and 299 is valid. These are the valid inputs. Center is valid. 101 is valid. 100 is also valid. Okay, just we are checking whether system is functioning properly at boundary or not. At boundary means exactly boundary and just below the boundary we verified. Also center verified. Any guarantee that all users are giving the legal inputs? Definitely no. So if the user is given invalid input, then how the system respond to the input? Okay, so that testing is conducted here. See this. This is the invalid and invalid. This is invalid. This is also invalid. When the user is giving the invalid input to the software, how the software respond to the input? That will be tested here. That's what in the robustness testing. In the robustness testing, more errors are possible to cover at boundaries rather than the center of a input domain. Okay students, I hope you enjoy the session. I hope you understand the meaning of robustness testing. Thank you all.